How's it going, everybody? It's Liv, and today we're going to be looking at a little bit of inter-process communication and some remote procedure calls as well. So, alright, how are we doing this? We are doing this through sockets, okay? I'm just going to give you an overview of the system. Then I'm going to show you a little bit of the implementation and discuss the nitty-gritty of that implementation, okay? But generally, it's just you utilize this package that's via, for like highway, right? We need to provide a host name. Right now we are using domain sockets, right? So this is basically, you could think of it as a file, basically. Just that the communication can be bidirectional. And we do have to utilize frames. Now, if you're new to this channel, what does frame mean? Frame is, think of it as a container for instances of a class, right? So there is some attributes that you want to be common across multiple instances of the same class, but you don't want to make them class attributes because those values are specific to a particular context, right? So basically we could have multiple instances of this network manager. Is basically what this VIA is. It is basically a network manager, right? And so we could have multiple network managers and multiple networks theoretically existing within the same process, okay? So that's the reason why we do this. And so what we do is we create a new instance of this manager, right? So we create a new network. Give me a sec. Okay. All right. So, oops. So all right. All we have to do is just open up this thing, right? So fairly simple front end, right? You just give me a frame, give me an instance, and open that instance. This basically just creates a socket, right? Then next up, we split, which essentially is a fork, right? The thing it does, I can actually show you the implementation. Oh, it's not here. So where is it? It's not here. Here we go. Okay. So it is essentially a fork with some error checks, and it sets the frame to undefined on the child, okay? So why do we do this? Well, here's more or less the reasoning behind this. First and foremost, I wouldn't really be doing this kind of inter-process communication. Like, generally, I wouldn't be doing it, on the same program, right? I wouldn't be doing it with a fork. Right now I'm doing it with a fork just because it's easier to demonstrate this utilizing a single file, right? So basically this is the network manager, and this is, any node on that network, right? So we are doing a little bit of a peer-to-peer kind of thing. That's the aim anyhow. And so the reason why we undef the frame on the child process, so on the network node, is because anytime we need to access any data relative to the network manager and to the network itself, we are going to be asking the manager for it, right? And while we're in the topic of asking the manager for doing something, how does a node connect to this network? All right, that's a good question. First and foremost, we need the host name, right? So this is basically, right now it is only a file, right? And this file is, give me a second. So we have this little module organizing our paths and stuff, and it has this subpath within our root directory, which is mem, right? So this is just a path to give to a certain directory, and by default is going to be using .mem, which now is empty because we are all linking every single file after usage. But anyhow, and so basically this will just go into our path .mem, right? And it will just create local.socket, right? And so what we have to do, we have to provide the path to that socket. If we were doing this with how do you say, with an internet connection, we would have to actually specify an internet address, right? But because we're just doing domain sockets for now, it's just name of file, okay? So anyhow, we need to provide the network itself, so the address to the manager, okay? We provide that, and this is just a nice little wrapper, which basically does a ship. And yeah, harbors and ships, it's like, yeah, it's like maritime themed networking. But anyhow, we send a package to the network itself. So it's basically the process talking to itself, but in a sense, it could be any program speaking to the program that runs the network. Okay. And well, it just wraps the call in a nice little way. And look at this. We have function key and class, right? So what do we do with this? On the other side, so this is on the side of the listener, so the network manager itself. So it could be any other node. What we are doing is we take the message and we read the header of the message itself. We get here on the other side the function key and the class, and then later on we call that function via that class, right? So this is basically doing a subroutine invocation, but remotely. Okay. So that's kind of nice. You can have one process do all of your managing stuff, and you want to retrieve some data. You can just ask for it. You can just make a request for it. Furthermore, if we are returning objects, right? So any kind of Perl object, or at least most kinds of Perl object, what we can do is freeze them, and we utilize the special network freeze kind of call here. And what we do is we give back the header of this message itself, just containing detail about the package that we are utilizing to send the response, and the package itself, which is just either an object or the return value of whatever the function returns, right? And so on the other side, we receive our we receive a response right back, and same thing. And if we happen to get an object back, we thaw it. And so if we ask for an object, we ask the network to create an object, the network creates it and returns it right back to us. So let's see what the front end for that is. I sort of changed up the order of operations there, but never mind. So anyhow, we can ask for we just ask for a new harbor, which is basically a node within the network that can listen and that can receive messages and send messages. Okay, we ask for that node. Okay, then here I'm just for demonstration just printing out that node that we just created, just to show you that it has arrived. Then what I'm doing is I'm just trying to get the node itself, right? Because maybe I don't know, maybe this instance you have here when you created it goes out of scope or something. but the object itself still exists within the network, and so you can ask for it again if you happen to lose it, or you need to have a handle to it. Now, the cool thing here is that this works through, how do you say, through the process name. Okay. So basically, your process will have how do you call this? So each process would have its own node. Okay, we could change this, right? So when we go into new harbor, we could make it so instead of being the name of the process, that it is the PID, right? We could do that, yeah. But you know, you can have some control over the, you know, at least theoretically, you can have some control over the name of the process itself, modifying the process ID, you know, like the numerical process ID. No, you shouldn't do that. Like, I don't even know if you can, but if you can, you shouldn't. Right? But the name itself is something that really doesn't matter, right? So you can just modify this, and that would be fine. So anyhow, then we just print out the return from the get harbor, right? So get node in network, matching the process name. We just print that out again, just to demonstrate that it is, in a sense, the same object. And then we just sync it, right? So sync is basically terminate. Well, you know, just to keep with the naming. And so yeah, let's just run this and see what happens. And yeah, and by the way, the net will run until there are no more nodes in it. Okay, so on startup, it will run indefinitely. Then whenever a node is created, it will keep running for as long as that node exists. And when all nodes have been sunk, it will cease to exist. And that's that, okay? A cool little thing. Let me see if I can find it. Oh. Well, it's going to take me a while, so let's just demonstrate this, okay? So, alright, it should be a test via, and here we go. Let's zoom in a little. Oops, okay, let me run that again. Okay, so you see, on one end, we receive the request, which is basically create a new instance of this class, and here are basically just the arguments, right? So it's hostname colon name of process, okay? And this here just means that the response from this request arrived safely, okay? And we can see that it arrived because when we print out the new node that arrived, it gives us an instance to buy a harbor. So we know that the initialization returned an object, okay? And that the freezing and thawing of that object was successful. Furthermore, when we make a request to ask for a node matching the name of the process, we get it back right away. So, well, you know, kind of nice. And then finally, when we sync it, we get back that it was sunk, right? So it was destroyed. The response arrived here as well, and finally, the network local is sunk. So, pretty cool, pretty simple. So, let's take a little deeper look at the implementation details, right? So, if you don't care about the implementation details, you can just you can just go off now. Yeah. But what I would like to do is show you, give you an overview of how the code works, and then demonstrate how to extend it somehow. Okay. So okay. So first off, it's the way we encode messages. Okay, so when you're utilizing sockets, you have send and receive, right? Now send, you can just give it a string and it will send it. No need to specify a size. But receive does require you to specify a size. So you can say read into some variable, right? So you say my variable, and read into variable, and you have to specify a size, right? So if you have, if you're sending strings or any kind of variable size data, that becomes a little bit of a problem, right? So the solution I came up with was simply just do it the old school way. Just create a header, and I'm doing this with a little utility here. So this is for creating structs. So it's analogous to C struct, but in Perl. Okay. So this will effectively create a data structure, and you see here we have a single byte for sigil. So this corresponds to the table of requests that we want to fetch the function call from, then a function key, just 7 bytes, and then the class itself. And this is longer because, yeah, like I'm not going to be codifying every single class that I want to instance from, to find methods from. Then, the source, destination, which we are not really doing anything with these two right now, but, in the future it's nice. And the one that we actually care about, which is the size of the package, right? So we have a fixed size for the message header, right? And then variable size for for the payload, right? And so this is probably not the most TCP friendly way to do it. Like as I understand it, that TCP has like different rules for how you have to format the packages and stuff. But I don't care. I don't care about TCP. We're doing domain sockets right now. So if we ever have to do TCP, we would have to create a different header. But that wouldn't be PESONet. That would be TCP message header. So I rest my case. Anyhow. Another thing, yeah, right, so I should mention this, we are utilizing Unix sockets. If you're on Windows, tough luck. But but anyhow, what we do is we just take from the message struct, right? From the message struct, we take size, and basically that says, okay, so read in the message, but just the header. Then from the header we can take size as well, right? And so basically we have to do this thing twice. So read in the header, take on all of the details that you need to, and then when you have the size of the message, just read that in as well, right? And generally you would do it in a different variable, right? So that's one thing to consider. So, how does the encoding and decoding of the message work? So that is just done by my type class. So if you want to go on ahead and read through these, you can. It's open source, so you can read it, no problem. And basically what it does is it takes a key value array, actually a hash. So actually, no, not quite. Bytes array. So what this does, I'm just going to very quickly summarize. It takes a hash which has all of the keys out of order, and then it orders them according to the order in which the struct was declared, right? So you can just write the members in any order, and they will just written in the correct one, okay? Because that's kind of important. Furthermore, if there are some members of the struct you did not specify, just a null byte will be put in place. Pretty cool. And we have a bunch of niceties in here. You can go and read the code if you want. The code, on the other hand, takes a string of bytes, or just a bytes object, let's say, and basically does the inverse, right? So it gives you a how do you call it? Yeah, it gives you a key value array, right? So this is basically this, key and value, right? So you write it like this. You can say, for instance, my array is equal to some key and some value. Okay, you can make a list out of this, and then when you want to access this like a hash, you can just say my hash and just this, right? So you can convert you can convert from the array into a hash if you need to, but just to preserve the correct order of the elements, I like to do it this way anyhow. And yeah, if you want to read more on the implementation details of that part of the code, you can go on ahead and do it, but just to keep this somewhat brief, we're not going to bother. So okay, let's take a look. I'm just going to close this one. And what else do I have open? Oh, it's okay. All right. So, just one detail that, now that I think about it, I'm not entirely sure why did I do this. We are utilizing a pool, so we have a fixed pool of possible messages, right? So, because we are handling this with these C-like structs, I have another class, kind of unrelated to this whole thing, but which basically lets you manipulate memory like it was like you do in C, right? And to this we just allocate a fixed number of this header structure, okay? And then we utilize this cask class, which is basically an array, but the way it works, you can say my object equals cask take, right? And it will give you the first value within that array that is not undefined, okay? And so you can take from any place, right? So you have a fixed amount of objects, and you say, I want any object, I want the first available object that I can use, and you can just take from it, right? And then when you're done with the object and you want to give it back, you just give, right? Simple. So yeah, that's basically cask. And the idea here is that you have a limited amount of objects, because you'd only be managing a fixed amount of requests at a time. So I went for 64 just because, but in actuality, I think we are handling just 5 requests at a time, probably. Oh no, actually 1. This is kind of pointless, but yeah. That's fine. That's fine. But yeah, this is basically that. Just the queue size. So actually, let's make that queue size. And let's say, well, for now it's 1, so let's make it 1. Why not? And let's be consistent with here. Okay. And I'm actually not going to bother with this. We're just going to do it like so. And if we ever need to modify the queue size, then I guess we should not make this a read-only, right? But if we ever change the queue size, we would need to resize the memory block that contains these headers. So yeah, little details we would need to handle later on, but we'll do that later on. Okay. If we go into the sending of messages, you can see that here's exactly what we are doing. We take object from the pool, we fill it out utilizing this encode function. So because I'm sorry, because we are utilizing the block thing, which is somewhat like manipulating C memory. We also have within block more or less an implementation of pointers, right? So we can take sections of that memory and we point to them basically, and just manipulate that memory through the pointers. And so the pointer itself, which is the object that we've taken from the memory pool, has a wrapper around encode. So the pointer knows which type it is, right? So it knows its own type. And so if you pass it a hash containing keys matching those of the structure that pointer points to, then you can just write that data into the memory block. And so we have more or less a full way to write very compact headers, right? So we can write very, very compact headers just as raw bytes and just send them. And the size of this is something like 64 bytes, something like that. And it's 64 bytes for any message that you want to send. It's not quite so much. And we could bring it down, right? So we could bring it down by quite a lot, actually. I don't really have much of a reason to do it right now, so yeah, I didn't bother. But you could rewrite this slightly, modify this slightly to utilize even less memory. So kind of nice. So anyhow, well, I don't know what else I should talk about a little. Maybe the listening. Okay, so the way the listening works is just this infinite loop, right? So for as long as you have connections, right? So for as long as you have nodes in the network, right? So unless this cask is empty, we also use a cask for the nodes on the network. If your list of nodes is not empty, then you keep on listening, right? So that's basically what this does, and it just it receives, decodes the header, takes some information from it, namely the function key and the class. Then with the information from the header, it reads the rest of the message. It notifies us, just for debugging purposes, it notifies us that the message actually got there. Then we just because what we are doing here for the most part is remote procedure calls. What we do is we just treat the we treat the package itself as you would in how's the syntax? So this is char char pointer argv, right? So basically it's an array of string, right? And we split by spaces, and that's the way we do. And and then we just take from the memory pool, we take another message. We share the sigil. So the sigil is basically which subsystem you're trying to communicate from, and depending on the subsystem you're trying to communicate with, right? So the sigil denotes the subsystem you're trying to communicate with. And for now, we are only utilizing at for net request, right? So at for net request, okay. And basically what this does is you read the first byte of the header, and you already know which table, which lookup table you need to use. You could make this larger. You could make it less than not less, more than a single byte. But for my needs, 1 byte is enough. So that's kind of cool. And if we if we receive if we receive a message for a particular subsystem, we want to match that request, that sigil on the response. You know, this is not something that's entirely implemented, so yeah, it's bound to change. But anyhow, so basically, we look up the function key within our request table, which matches, where is it? Which matches this, okay? It's just, some key, and then the actual name of the function. Actually, what we should do here is generate from a list of names a list of indices, right? And then instead of writing the function key as a string, we can write it as an integer, right? We could make it, right, this particular table we could encode as a single byte. Why don't we do that? Why don't we do that, and we could do that as well with the class, right? So right now I'm doing this because this is like the early implementation kind of mambo. But actually, it would be kind of nice to, codify it away. Well, tell you what, let's do it. Okay, so first off, I'm going to make it wide, which is basically 16-bit. Okay, so we're going to utilize wides for this, and we're going to utilize wides for the function key as well. Okay, and we're going to utilize wides for the class as well, and that leaves us with, that would be with 6 bytes. We have another 6, another 2. We have another wide, and that would be the full word. So we have a little bit of a problem here, because I do want to use a full size word, and this is 64-bit words. Okay, I do want to use full words for the source, destination, and size. For the most part, for the size, the destination and source are not really doing anything with them right now, but just to be nice about it. So, what can we do here? Because here we would have 6, and here we have 888. So I'm counting in bytes, by the way. So that's 24. So yeah, we are 2 bytes short. 2 bytes short of 32. Well, I can just add a manual pad, right? So I can just say padding, right? I can do that. But it kind of hurts my feelings to throw away 2 precious bytes of memory. It's not something I like. I should use these for something. Well, tell you what. We can say something like this. So long is 4 bytes, right? So we are talking about a 32-bit int, okay? Right, so then we have 2, 4, 8, and 24, that's 32 bytes. Nice, okay. So yeah, let's do it like that. And why utilize wide for class and sigil? We would have less lookup tables and classes linked to those lookup tables than we would ever have functions. That is my thought process there. So anyhow, now what we want to do is basically have a way to convert from a given name, from a given function name, to the index, right? So actually what we should do is do it like this. and then we can generate that table. Okay, let's think about this. Oh, like that. Let's say, let's begin with net, get here, and sync. And what we have to do then, oops, I don't need the commas, I use QW. Okay. So let's say rectav indices, okay, and this one is going to be a hash, and what we have to do is say, give me, I can do it with a map. I can say map. Oh, but I'm gonna need, okay. Okay, don't worry. So I can do it like this. I'm going to say our rectav I, just going to make it blank. What I'm going to do is write on an init block. I'm going to do a little bit of mapping. Okay, so how do we do that? We want to have, for each one of these values, for each one of these function names, we want to have the index associated with it. We are going to utilize that index to encode and decode the remote procedure calls, right? So if we want to call net, we have to ask for function name 0, but the more comfortable way to ask to call function number 0 is to say call net. Okay, so we want to say call net, right? So we want to do the calling like this, and then within the function we want to say request name of net, right? And that should give us the index of call, right? Nice. We can do that, and then on the other side from index of call we can get the key net itself. So what we have to do is an inversion of the hash. Okay, so for every key in the hash we need to create an equivalent saying net equals 0, for instance, and get peer equals 1, and then we have to do the inversion of that hash within the same object, you know, just to be cleaner about it, if you will. Or we could do it in another one, doesn't matter, right? And so it works like this. Okay, is that nice? We could do the reversion of the hash within a separate object, and that should be fine as well. So actually let's do it. Okay, so let's say names, and let's say indices. Okay, all right. Actually, I'm just going to shorten this. Okay, so N for names and I for indices. And I can't make this read only because I have to assign to them. So actually, maybe there is a way to make it not read only, but whatever. So anyhow, we have an index, and that's let's begin that at 0, and we want to map arg equals I, and we augment this. Okay, for each key that we have in the request tab. Okay, so this will go through every one of these keys, and it will say, okay, so key equals index, and after assigning the index will be incremented, or rather, you know, this will return the index before incrementation while incrementing the index, whatever. Okay, and that gives us our list, and that is request tab names. Okay, and so then request tab indices would be reverse of request tab n. Okay, so actually I have another function to do this inversion within the same object, but because we are not going to do that, this is good enough. So okay, that solves our little problem. So now we can encode these we can encode the class and function key as just plain integers. Actually, not the class itself, because now that I think about it, we do need to have a class table. So that's more complex. And now I remember why I made it so the class was a string. So okay. Well, I mean, basically it's the exact same idea. So we have a list of strings, and we need to turn each one of those strings into an index, and then be able to have the mapping go both ways, right? So it's just it's just this, right? So create list, make the two hashes out of that, basically just inverting one. Well, so would it be nice to have this within a single class, maybe? Why not? Because I mean, if whenever you have to do something more than twice, it's nice putting it in its own block of code, right? So you can just call that and be done with it. That's kind of nice. That's kind of nice, isn't it? Likewise, it's kind of nice. It would be kind of nice just being able to make this a read-only, right? Because we are not going to be modifying the request table at runtime at this. I don't think so. Furthermore, I could make this be just a single line if I did that. Because we could have, say we have a table, and we say names, and that gets us this, right? And so you can just, you can just create read-only our table, and that's all you need, right? So you have all these two hashes within the same object. That's kind of convenient. So yeah, I want to put that into its own class. Huh. Okay. Wow, what the hell? Let's just do it. It's okay, let me think of a name. What could we name this? So this is to convert strings into indices. So let's call it streetx. No, that would be dumb. Why not string tab? So table of strings. Yeah, why not? Let's say or system string tab.yum. Let's say I don't need to do this bit, but just in case I ever want to make these into executables. I never will, but yeah. Yeah, that's the thing. Okay, so string tab, table of strings, and we want to say this is Libre software license under the new GPL tree, be a bro and inherit. Okay, nice. So contributors, live, and that's me. Okay. Let's let me just do this real quick. So this is going to be package string tab. I want to use version 360. 5360. And warnings. My shift key is kind of not working. I have to get a new keyboard. And that should be about it. I don't think I need much more. Okay. So let's just do a knit, and we take class and data. Okay, so this is just a straight up list. Okay, data. And oh yeah, I know one thing I want to use. I need to take from my live. Oops. From the system live, I want to use SD. Okay, so SD is just it's like a base class that has some nice utilities for using frames. I wouldn't need frames for this, but you know, it has a method that's what is it? Get class, right? Which is basically just a wrapper around a ref object, right? But I think it's easier, it's clearer to say object get class than ref object. It's and you know, if they ever change what ref returns, I can just change the implementation on one function rather than having to change it everywhere I use ref. So yeah, it's kind of, you know, just one of those things I do to cover my ass. It's okay. Let's just say I want to have my and actually I have already this written in here, so I can just copy and paste. Nice. Okay. So you know, same thing. We just take index and let's say names and indices. There's names, okay, and I actually have to wrap this like this because this map will return a list, right? So a key value list, okay, and so I have to wrap that, and we just do this from data, not date, and then just reverse this, and okay, and that we can just return a blast of we want to take names equals names and let's say index equals indices. Okay, basically this will allow us to fetch the index of a particular string in the table or fetch the string itself from the index, right? So that's the idea. And we want to instance from class, right? So then we can subclass this no problem and still use the same initializer. That's kind of nice. And then say my tab equals list all of this, and then just return the table. Okay, nice. So now we can say our request table is equal to string tab knit qw and the list itself, and that's a wrap. And that's a wrap. Yeah. All we need now, all we have to do is just include this and use string tab. Okay, nice. One thing I have to do actually, I have to add this to the list of modules that I want to import. Cask, so I put it after or before? Yeah, after. Okay, it doesn't really matter, but you know, just just to be somewhat orderly. So string tab.pm, and yeah, because I'm editing this, because I'm writing this code as part of my auto build system. Yeah, I have to include it. I can't just have it be done automatically. That wouldn't work. So yeah. You know, I need to write this setup script for my setup script generator. So that's kind of weird, but yeah. Okay. So now we want to do exactly this, but for the list of classes. Okay. So we'd say KLS tab, so KLS for class, and instead of all of that thing we did before, we say via and via harbor, okay? And that's a wrap. Okay. So now, when we make a request, instead of taking the function key like this, you would have to do request table what do I want? I want the index, right? So we take index of get peer. Okay, get peer, and you know, just have to do the same for the class. Okay, index, and this one I do have to stringify. Okay, there we go. And it looks kind of weird if I stringify one and not the other, but whatever. Okay, let's do the same for the other ones. Actually, this is TLS. So class tab, give me the index to this particular class. Okay. And now the function could be, in this case, net. Okay. Let's see, get peer, right? What? Give me a sec. Oh, right. Okay, that's just fine. All right. Just making sure that everything is fine. Now, here we did function key. So what I would do is just So this is for a response from the system. So you wouldn't be expecting to get on the listeners on the client side, let's say. You wouldn't expect for a request to arrive. Okay, so basically function key is just message type, if you will. So maybe we could, instead of that, we could say class, right? And maybe that makes more sense. And so, well, we could say something like that, maybe. So I could use the sigil followed by an index. Yeah, I could do that, but that would be a waste of time because I already have the sigil right here. So no, that's a stupid idea. So okay, I'm just going to do it like this now. Just going to do it like that, and that's going to be a wrap. And then when I have some more time, I will do the thinking. But for now, okay, that's fine. What I should do is I would have to modify this part over here. Because now this is a wide, right? So I would have to convert it into a number. I can say no, ord, right? So I should say ord, and I just have to put a null byte after it because I'm not going to be doing anything else. Yeah, that's fine. Okay. That's done, and this is done, and now what else? What else? What else? Oh, right. Two things, okay. So first I need to take a look at the class here rather than the function key. If it's 1, we know it's an object. If it's 0, it's just a value, right? So that's a plain scalar. And right, so I need to decode the right. So here, I need to take from the request tab I need to take to get the name of this thing. Right. So, right. So this should be inverted. So if I want to fetch by name. If I want to get the name of something, then I'm sending it the name. If I want to get the index, then I'm sending it the right. So yeah, this is kind of stupid. It should be the other way around. So I want to get the name of the index that I get from this. Okay. And same thing in here, but for the TLS. Okay. So from the class tab, get the name matching this particular index that we've received, and that's a wrap. And now with the function key working, right? So this doesn't make any sense. So I was checking for the existence of it, right? So actually, what I should do is the find function key, right? So I don't need to do this translation anymore. Right? And so we just say class function key call with arguments, and yeah, we always have to send the frame for the network manager itself. So that's kind of not so nice, but yeah. We could swap this out with another frame if we had another, but yeah. So about an hour. Okay, an hour of coding. That's fine. Okay. Right, so I'm thinking in my head, will this work? I think I might have made a mistake here, but just in order to find out, I'm gonna have to first run an update, and that's fine. So let's try test via, and aha. Okay. Yeah, I forgot to do this. Rebuild, and let's try that again, and symbol arg, I need English. That's fine. And there we go. So 1, 2. I must have left some doodles hanging around. Let's see. Oh, 2. I need 2 parentheses. Okay. $102. What you talking about, Willis? Okay, so I know it is complaining about this, but I already put the 2 parentheses. So what are you talking about, Willis? What are you talking about? Huh. Let me try this again. Okay, let's debug this. Holy fucking. Okay. Okay, so you are not updating. You're shit. You've been bullshitting me this whole time. So, like, fucking update the damn thing, okay? Oh, because I need to run auto. What a fool. Okay. There we go. Alright. Assignment at 75. Right. Okay. Try that again. An array reference at 298. Oh, yeah, right, because I don't know, I no longer need that. Okay. Update. And it's in the market pack. Oh, so I can just put a 0 in there? Oh no, it will automatically be converted. Okay, that's fine. Okay. 312. Thing 2. Okay. Alright, so it inverted. Okay, so it inverted. It inverted everything. That's not what it was supposed to do. Alright. Well, there's another thing we can do. Basically, just repeat these. Let's see. You like that better? Right. Take from empty cap. Alright, but it this is funny, right? Because we had a pretty catastrophic crash in here, but it did manage to create the object. It just didn't quite get to solving the get request. That's kind of interesting, but 2, 5, 7 complaining. Okay, so the message pool was empty. Oh, because we never gave back the message. All right. I mean, theoretically, once we've already sent the message, just give back. Okay, let me get something on real quick. I might have. Right now, that's fine. I was afraid for a second that that had created a dangling like ghost process, but no, so that's fine. Okay, so let's run it again now that I know that it's not going to break everything. Okay, so class is uninitialized. So it managed to do it managed to create the object. It managed to get it from the network, right? So it could create a new object on the network, send it back to the calling process. Then it was able to receive a GET request and give us back the exact same object. Just the address is going to be different because it's going to give us a copy of it, basically. Not like a soft copy, not a deep one. But then on the sync we had a problem. 320. Oh, I know. Give me a sec. Fuck. Okay. All right. So in sync, this is kind of bad practice now that I think about it, because what I'm doing is handling both the remote version of the object and the actual object in the same function. Like, yeah, it's kind of weird, right? So it allows you to just call it allows you on the remote object to call the method as if you had actual control of this, but not really. So yeah, you have to make a remote call. But anyhow, do I have to specify the state field? I guess I do. Do I even specify it in here? Or where am I? Okay. Well, we do specify it, so whatever. This is fine. Okay. So now at FN key, it should be via request tab index of sync. Okay. And the class, this is going to be a slightly longer line, index of class of object, right? So yeah, we could write the name of the class itself, but then if we subclass this, then we have to rewrite the method, right? So no thanks. Okay, that should work. Did it work? Yes, it did. Okay, but not quite, because it assumed it was via, which is not. Let's try that again. And yeah, okay, so it's always getting the wrong class, not what I want. It did manage to sunk the harbor itself, because the on the allocation it will, on the allocation on when it starts doing the calling the destroy on every object, it will inevitably destroy it. But still, Let me try this. Okay, I'm just going to say ref bst. Okay, and here it's correct. So why is it trying to? Huh. It was giving me the right class, but what's this? It's giving me the correct class, but it's not sending it correctly. So what the fuck is that? Oh, because I'm doing rec tab instead of kls. What a fool. Okay, there we go. Done and done. That's that. Okay. So, all done. Okay. So we succeeded all 3 requests, right? So we were able to create the remote object. We were able to find the remote object within the network. And we were able to request the network to, actually not request, but, notify the network that we are done with the object. We can now delete it. And so the remote version, as well as the one on the network, will be just destroyed. Okay, so nice. Let's see, what hour is it? Okay, so we can do one more thing, okay? We have time to do one more thing, and what I would like to do is just implement a new request. It's not going to do much too useful, but I guess it's going to be nice for how do you say? I suppose it's going to be nice just for demonstration. Okay. So let's try this. We'll have a function that just creates a hash, returns us that hash. We will freeze it, and then tow it on the other side, and we'll print out its contents. Is that fine? Okay. All right. So let's try it. Let's say we can close this. What we'll do, we'll just add a new method here, and we'll say, I don't know, useless request. Okay. We'll just do the call within the main class. Okay. So we'll just implement it right here. And I'm going to delete these afterwards, but just to demonstrate. So what we have to do is we have to send a class and frame, right? So that's the obligatory fields, and then we'll do just let's say h, something like that, or now let's do it like this. Let's say like this. Oh, data. Okay. Because the way it works is you'll always have these two implicitly, right? So in a request, you'll always have these two, right? So a class and a frame. And then the actual, and this will always be passed as an array. So now that I think about it, I'm not entirely sure how to do this as a hash. But let's try it. Okay. So what do we want to do? I guess we just want to return during the thing as it is, right? So we want to turn it into a hash reference. We could do it like this as well, right? So yeah, it's a useless request because we could just create this hash locally, but just to demonstrate that it works. Okay. So now we have to actually make a message for this. Okay. So what I'm thinking is we could generate this hash just with another function. So let's try doing that. So these are the fields we need to fill out. Let's say solve make request, something like that, and we want to say function key and what's the I'm in class. Okay, right. Oops, my request equals all of it. Okay. Actually, I could do it like this. So now I can say class make request, right? And I only have to specify the function key. Pretty nice. So let's say for this one will be net, right? So something like this. Let's shorten this, or maybe not. Net request or netrec. Let's try that. Let's say request. I prefer net request. Or just request. I can never help it with the namings. Okay. Let's say request. We have to pass in net and the arguments, which is just this. And I guess the destination as well, but yeah, we do have to specify this. So actually, let's put the destination. We put it first. Yeah, it's a request destination for function key with given arguments. That's fine. Okay, that's neat. One more thing. which is kind of weird, right? So yeah. Hmm. This is weird. This is just weird. But yeah, let's just ref class just in case that it's not ST based, though it should be. I don't know. I don't know, but anyhow. So this is just so that if we call from instance, right? So we have an instance to this class, and we say request, it will be translated into this. So that's kind of useful. Okay. Request NIT to the network itself. So 0, it's always the network, and that's a wrap. Okay. Oh, but I need to do this from Harbor. Well, do I have the file open? Let's just this. I'm thinking. Why not slap it here? Right? Because if I'm already doing it remotely, kind of have to. Kind of have to slap this thing in there. And I can do self request. Aha, nice. So request, and I want from the network, I want to request sync, and the argument is self index. Now I can just. Boop. Isn't that nice? It's much shorter, right? So if I have to do a lot of remote calls, I can just shorten that. Which means now I can, on this side, I can do this, right? Yeah, the problem is I need to get the return of the shipping, okay? Right, so I have to actually return this. And I should be doing the same thing here. Okay. Alright, so it's kind of weird, but I accept it. It's kind of weird, but I accept it. Okay. So now rather than say new harbor, I can just say via harbor net, right? That's actually kind of nice. For the get though, I would need to do that manually, I think. Oh no, it's just get peer. I have to do another remote call. And I know I said this is a bad idea, but yeah, I'm tired. I'll figure out a better way to do it later on, if I ever do. Okay. On the remote, we can just ask for get peer. And what's the arguments? Let me check. It's name and index. Okay. Oh yeah, but this is kind of a problem. I had to pass all of that stuff. Okay, let's try this. Def on def and on def. It's kinda not so nice now that I think about it, but yeah. Yeah, I guess we should have maybe a different class for this. I don't know. But yeah, like having both things going through the same entry point, it's strange. Strange thing to do. So yeah, this what I should do actually is I should subclass this thing for the remote version, right? And then just rebless it or whatever. But just for demonstration, this is okay. But yeah, it's going to be confusing later on. Ah, shucks. Okay. So this is really messy, but that's fine. But if I'm passing in the name, why the fuck do I need the index itself? That doesn't make a whole lot of sense now, does it? I mean, it does allow for a single process to have more than one what do you say? More than one node, right? So that's probably useful, but I mean, it just seems confusing. Like how often would that even happen? Okay, whatever. can just get rid of this too. Now let's see how spectacularly that fails. And just a single syntax error, which is disappointing. I was expecting a longer error log. Let's see, it's because I left this thing. Yeah, okay. All right. Yeah, okay, so I need to adjust the initializer. Okay, no problem. First and foremost, this one is knit. Oh, okay, got it. Got it. Right, so I can't do it like this. Huh. One, it's going to throw me into an infinite loop. So that's nice. That's charming. Let's see. Do we have a ghost? No, we don't. Okay, nice. Hmm. Yeah, right. Like I would have to do a subtract for this. Hmm. Mm, yeah, I think it's the easier way to go. I think it's the easier way to do it. So let's just do it. Okay. So alright. We'll do this via remotes, I guess I can call it, but I'm gonna say oh no, I know. Let's make a new folder actually. Let's say this here. I guess I could make it a subfolder within it, and so then you say via remote, right? And then the class itself. That works, I guess. I mean, it doesn't seem so clean. Well, that's fine. Now we say sys via remote harver.pm. And let's copy this whole thing. I'm not going to need the entire thing, but yeah. Just so I don't have to write it by hand. Okay. Via remote harver and remote via harver. Redirects calls. Okay. Right. So what do we actually need in here? We're not really going to be needing the parent itself. I don't think so. We will need to use via just for the constants and stuff, but that's fine. I guess I should have a remote base, no? Maybe. I don't know. Let's just do the raw approximation of this. Okay. Yeah, we would have thought that doing remote calls was this complex, right? Yeah, it's just what happens. You know. Right, so if I'm trying to launch the request like this, then I would need to use parent. Else I don't inherit this thing, so yeah. Actually, I should generate these calls. Because check it, it's always the same. It's always the same thing. Yeah, I should actually generate these files. So I can work on that later. Right, because it's just, you know, it's some call self arts, and then it's just this block, right? So I should have this as a variable, so DST, so destination address, and then it's just DST itself, then call name, then just copy and paste the arguments, right? So this thing can be generated, it should be generated. Okay, but yeah, just to get it done now. So let me just check out what I need to change here. Right, so this is the problem. Right, we need to pass the net address. Wait a second. Just a second. Oh, I still have this. Oh, okay, that's fine. Yeah, I need to copy this thing over here. So for the initializer, because I don't have the because the initializer I do have to call through the class, right? So I do have to call it like this, but I can get this and to which net I want to connect, and that would be local in this case. And local is not the full path, so I have to generate the full path, and I get that from doing this thing over here. So okay. I can actually do it like this, why not? Alright, done. I can actually say just ship, I believe. What's that? Let's do it like that. Okay. Now this I would call true self. And for sync, I only need self. Okay. One more thing, okay? On the request generator itself, I need to remove remote, right? So just pop that off. And that's a wrap. Okay. So we'll just we'll get the actual name of the class from the name of the remote class, and that's fine. Okay. See what happens. Oh, I actually need to add this. Oh, I don't need it. Okay, nice. So let's just install. Let's see if we get any errors. Okay. So you're just rebuilding my system. Never mind. Now if I call auto, it should have, yeah, here it is. Okay, so it updated it automatically. That's nice. I don't have to add it onto the list of files, so that's refreshing. Okay, so let's try it, and it's probably going to fail, but okay. All right, so that should be in the request section. Create. Oh, what a fool. Yeah, right, because this is now useless. Okay. Now I can get rid of these. It's on the remote side. On 48. Oh, I forgot. Okay. All right. So it the message arrived, the initial message. Oh, because I don't have it loaded in. Okay, that's fine. Right. Now, what I would do is just to have the remote just include the class it's supposed to be. Okay, so it managed to create the instance. Okay, so that's fine. But here we have a problem. So 108. Okay, so what's the matter? I don't have that problem anymore. I must have missed an argument. Oh. Oh, right. Okay. Right, because I have to rebless it. Shit. Okay. Give me a sec. Yeah, so I'm just going to rebless it. What the fuck? So let's see. It should be on ship. And when I pull it out, what I need to do is get the class of the object. And I need to insert remote. Okay, so the way I'm going to do it is just oof. Oof. Where should I put it? No. Wait, what am I thinking? On the remote initializer, and just say bless this reference that I get with class, and there you go. Okay, so now, yeah, right, so now it's a remote. All right, so we have some more problems. So we did receive the correct message. So what's the problem there? 386. It says that package is uninitialized. It's not correct. Get peer, and that it doesn't recognize that. Okay. curious. It's right here. Like what? So this will happen when the return value is not right. I must have messed something up here. So it found nothing, basically. That's what you're saying. Found, and it would give me nothing. Right. So nothing. It found nothing. Okay. Right. Okay. So something is wrong with the... Oh, the name is wrong. The naming is wrong, right. It's not... Okay. Right. Right. Because it's searching for a name that's not the correct one. Isn't it? Isn't that right? Right. So here is the real name of the harbor, and here is the name it's trying to look for. That's not correct. That's not right, but why is that happening? Hmm. Oops. Right, so it doesn't include the original name. That's incorrect. The knit. Right. Here's fine. Okay. Okay, so now we can find it. All right. Okay, so my request was wrong. Okay, it's fine. Okay. And 48. We can get rid of this. Let's put some harder. 48, and we can get a view on an on an unexisting index, right? How is index? How does index not exist? Okay. How long have I been recording? Almost 2 hours. All right. Let's wrap it up. For some reason, it cannot find it. Oh, because I didn't. Okay. Because when I made the request to get the peer, I did not rebless it again. That's fine. Okay. This should be called with self. Which means I do need SD. Okay. I do need SD. All right. That's fine. Oh, but I'm using Via as a parent, so I should have all of the methods from Via. And now that I think about it, I can probably do it like this. Okay. So I actually need to rebless this thing. All right. There we go. All right. So we ask for a particular class, we get a remote version of that class, which is basically just wrappers around the requests that we need to make in order to interact with the actual object. Okay. So we are dealing with remote procedure calls and remote objects. So what we get is a handle to something that's sitting on another process, right? So we it's kind of weird to think about, right? You have a handle to memory you don't directly control, so that's kind of crazy. But anyhow, we are able to initialize a new object. We are able to find objects within the network, right? So if we were to instead of passing the name of our process, we were to pass the name of another one, we would be able to find other nodes in the network. Finally, we are able to tell the network to destroy an object because we are done with it. So that's nice, and we can do this all via the remote, which means now we don't have to. We do have to sort of implement each request, which is a little bit of a pain in the ass, but that's fine because yeah, we can do all of this. So anyhow, the last thing I'm going to do is I'm going to implement a new request, right? Because I said that's what I'm going to do, and I got tangled up in re-implementing all of this shit. But anyhow, so useless request, and we want to get just a hash, right? Okay, so let's try it. We want to ask via, but want to ask via itself, but via is the parent of Harder, so we can probably do it through our class here. Okay. All right. We have. Just check. We did add useless request to our possible list of requests, so that's perfect. So what do? We have to create on our remote a function that makes the useless request. So useless request, we're passing self and the hash, and we have to sort of copy and paste this, but we don't have to rebless this time. So nice. Okay. And we send to the net itself. Doesn't really matter at this point, but you know, if we had to access any kind of data that only the net would know about, then we need to do that. So to get a handle on some other object, or to delete an object, or to create an object, we do have to communicate with the net itself. But for this, it doesn't matter, right? Because we are not asking for data that only the net would know about. But anyhow, so let's just do a useless request, and with the arguments would be h. Okay, so let's see what happens. Let's get rid of this because we have already confirmed that this thing works. And let's say my hashref is going to be dst useless request, and we want to say key value, right? And basically what we get on this side is just this thing. So let's use fmat, or I'm not already using it. Okay, let's use fmat and say factdump h. So basically this will print out the hash that we get on this side. So let's try it. And we get key equals value, right? So basically, you know, it's a useless request because it's just, you know, it's passing this data through the net, right? So it goes onto the manager. The manager processes the request, it forwards it to the actual implementation, and all it does is just gives us no, like a reference to that. Then it freezes that object, it sends it through the network again to the remote, right? So it sends the object back to the remote, and then the remote just stores the frozen object. And yeah, so it's a useless request because all we are doing is just passing the data through the network, getting the same data back again, and printing it out. So it's like we don't really have to do that, but it's just to demonstrate that we can send data through our request and get the same data unscathed, right? So so basically the idea is that our inter-process communication works exactly the way we want it to work. So yeah, that is a wrap. That is a wrap. So anyhow, what time is it? Okay. So yeah. I don't think I have much else to say about this. It's a nice little system. It has a lot of things I have to iron out, as you can see. But yeah, if you want to do, you know, inter-process communication at a somewhat higher level, this is pretty okay for that. Of course, there's probably no, the whole having to write the remote class. I don't quite like it. So I will have to look into probably generating the code for the remote calls. But that I can actually do fairly easily. So when I get into that, let's try that. And yeah, that's it from me. Have a good one. Bye.